Hello, everyone. Before we begin, I'd like you to take a look at the Slido. If you want to ask some questions at the end, you're going to have to use the QR code, or you can find it directly on the PyCon website. So before I talk to you, let's discuss who I am and why you should listen to me. My name is Sebastien Crocquevieille, but that's a little bit hard to pronounce, so you can just call me Seb. I'm a French and Mexican data engineer who works at a company called Numberly. I've been an Airflow user since 2018, and my last talk about Airflow was at EuroPython 2023. I've lived in Taiwan for 5 years, 所以我可以说一点中文, but not enough for this kind of presentation. I'm a big fan of course, Python conferences, open source, and self-hosting. So let's begin. So even though you just had the previous talk, I'm still going to introduce Apache Airflow a little bit because it's hard to do a talk without doing an introduction. Sorry, not sorry. So Apache Airflow is an orchestrator. An orchestrator means that you run jobs automatically at a preset frequency most of the time, and it helps you monitor their execution. Apache Airflow is an open source project before anything else. It's an Apache Foundation project. That means that its license is the Apache license, and they help around with the management. It has very active developers, and I'd like to take the opportunity to thank our Taiwanese contributors, if they're in this room. If we could just give them a little bit of a hand of applause. Thank you very much. Like I said, Apache Airflow has a very active development cycle. It has between 100 and 150 commits per week this year. So very active and very well maintained is what you want from your open source projects, especially if you're going to be using them in production at your company. Apache Airflow also has a very active community. So there's a dedicated Slack. It has active Stack Overflow tags, and it has an active subreddit. That way, if you have questions about Apache Airflow or you want to discuss it with people online, it's very easy to do so. And finally, for this introduction, there's a global event about Apache Airflow called the Airflow Summit this year. It will be in Seattle in October. I'm not going to go into too much detail about basic Airflow objects. If you want to know more about them, just look at the previous talk. But basically, what you need to know is that DAGs are workflows. And then for the rest, we'll discuss it together. So now that we've talked about Apache Airflow, let's focus a little bit more on scheduling. Scheduling basically answers the question, when is an Airflow DAG triggered? So the most basic kind of schedule in Airflow is the fixed schedule. We usually do it using the cron tab notation. That means that we have 5 groups of characters: minutes, hours, days, months, and day of the week. For example, if you used star, the star character means for every. So you'd run for every minute, for every hour, for every day, for every month. That would basically mean you run every minute. That's not a very realistic schedule. More likely, you'd have something like the one underneath, 081, so for minute 0, hour 8, day 1. And that means that you run for the first day of every month at 8 a.m. The fixed schedule solves most of the use cases. That's why it is the most commonly used in Airflow. It's very quick and easy. You type your cron tab, you put it into your DAG, and voila, you have a DAG that runs at a very strict pace. It can adapt to some simple exceptions. You can give it a time zone. If you give it an active time zone, it'll automatically adapt to daylight saving time. Trust me, I'm French, I know. If you use Airflow timetables, you can also get it to adapt to holidays, although that requires a little bit more work. But it's important to know that despite these exceptions, it is not a dynamic scheduling. It's supposed to be fixed, supposed to be frequent. There's 2 types of dynamic scheduling. The first, as was introduced in the previous talk, is event-driven scheduling. And this was first introduced in Airflow 3.0. This is an execution that follows external events. It's a little bit more complex to set up because you need to use a class called the Asset Watcher that monitors external events. And this uses triggers. So you have to put in a little bit more effort. But basically, backend developers will be very familiar with this. You have an external event. Every time the external event happens, you want to trigger a DAG. This leads to a few implementation difficulties because how do you ensure that your external event is always discovered? And then while trying to make sure it's always discovered, you have to be careful not to produce duplicate events that would produce duplicate executions in Airflow. And also you have to have ordering guarantees if your workflow depends on the order in which the events arrive. So that's a lot of difficulties. If you're in a specific use case that requires them, go ahead and do so, pile through the difficulties. But if you don't, there is another kind of scheduling called data-aware scheduling. And here, the slight difference that's very important is that we don't follow all events. We follow a specific kind of event that is a change in a data source. Ideally, for your DAG to work well with data asset events, at least before Airflow 3, you would like your changes to be indistinguishable. That means that it doesn't matter what's happening to the database or the file or the data source that you're tracking. You just want to know whether or not it has changed since the last time that your DAG ran. So with this idea come lower constraints than the event-driven scheduling, is that you don't need a one-to-one execution as long as your workflow runs every time the dataset changes. What this means is that if I put lots of very fast operations, like 3 or 4 insertions, and after the 4th insertion, my DAG runs, it doesn't care how many have happened, as long as a change produces a run. Likewise, because I don't know what kind of change I'm doing, I just know that the source has changed. It doesn't matter what the order of the changes are. If I insert and then I delete, or I delete and then I insert, as long as eventually my DAG runs, I'm good. So that means that we have lower constraints, and that'll facilitate our development a little bit later. Finally, data-aware scheduling depends on Airflow datasets rather than external events. So Airflow datasets are an internal object within Airflow, but it's important to demystify it. It's basically just a string. Okay. Here you have an example of an Airflow dataset. Like all Airflow objects, it's just Python code. And so you have dataset S3 dataset example.csv. So here it's an example of a file inside an S3 bucket. You can give it extras, but we're going to ignore that for now because it doesn't matter. This has been renamed to data assets in Airflow 3, but I did most of the work on this presentation before, so I'm just going to call them datasets. And what's important to know about datasets is that maintaining the link between the dataset, which is just a string, and the actual data source that exists somewhere out there in your architecture is your responsibility. So if your data source is modified by Airflow DAGs, then it's very easy. You just set up the outlet like we saw in the previous talk. And every time your DAG runs and modifies the data source because the task that has this data set as an outlet is a success, then the data set will be refreshed inside of Airflow. But if you have external processes that modify the data source, it's your responsibility to make sure that every time that process runs and it modifies the data source, you trigger the change in the Airflow dataset by triggering a dataset event inside Apache Airflow. Usually you do this through the API. So now that we've seen a little bit about scheduling and how it works, let's talk about upscaling our scheduler. The Airflow scheduler is the part of the process in the Airflow architecture that generally monitors all tasks and DAGs, triggers DAG execution, and in most basic setups, parses the DAGs as well. This is the process that triggers DAGs based off of datasets. So how do you know if your Airflow scheduler needs an upgrade? Well, like all things, if it has performance issues like high CPU and RAM usage, if your scheduler has heartbeat failures, which means that it's supposed to be sending a regular signal called a heartbeat that shows you that it's functioning well. If that signal is not being sent, something's wrong. Or if the time it takes to read to parse all of the DAG files is too long, those are signs that your instance might need to be upscaled. Things that are a little bit easier to see directly on the instance could be that you have a lot of tasks in a queued or a scheduled state. That means that they're not being executed as soon as they should. They're waiting to get free resources or for the scheduler to eventually go to them. Or if you have delayed DAG runs, for example, you've set your schedule to run every day at 8 a.m., but your DAG only gets triggered at 8:30. That means that there are 30 minutes during which the scheduler is not able to trigger your DAG. Finally, Airflow is known for being database connection hungry. That means that the more DAGs you have and the more you want to process in parallel, the more database connections will be opened. So you can also reach database limitations if you have too many connections or if your tables are too heavy and the queries become slow. So the first way you can kind of get some performance gains is by using Airflow remote executors. By default, if you just naively pip install Apache Airflow and start running everything, you will have your executors, which run your DAGs and tasks, and your scheduler, which processes all of that, running on the same hardware, sharing the same resources. But if you use remote executors like the Kubernetes executor or the Celery executor, you can send those workers to do their job somewhere else. So the pros of this is very robust. You decouple the workers from the scheduler. They don't bother each other. They're isolated. Everything works fine. With this, you generally run either on your own Kubernetes cluster or on cloud server. So that means that you can have a lot of worker parallelization. And because all you need to do is a rapid network call and then you have booted up your worker, it's also extremely available. So it's a very nice way to run things in parallel and gain more resources than just running everything on a single machine or a single VM. The cons are, if you're running on the cloud, it's going to be expensive. And if you're running on the cloud or you're running your own cluster, you have to know all the infrastructure set up to make it work. So it's either a cost in terms of manpower or a cost in terms of knowledge or a cost in terms of cold hard cash. But let's say you do that. You have Airflow remote execution, everything works fine, except your scheduler is still lagging behind. What can you do? Airflow supports scheduler replication. That means that you can have more than one scheduler process. If you're running Airflow with the Helm charms, it's as easy as setting the replica factor to 2. This gives you more performance and more resiliency because you split the scheduling load, and because if one of your scheduling processes dies, the other one is still up there doing its job and picking up the job of the other one. The problem is, just like with the increased parallelization with the remote executors, we have more database connections. So if we set this up and we have more database connections from the scheduler replication and more database connections from the tasks that have an increased number of workers, then we're going to have database problems. So what's the next thing we can do to increase, to upscale our scheduler? Well, there's not much you can do except have 2 separate instances. So once you have 2 Airflows, everything just becomes very easy because you reach maximum scalability. If you need more resources, just have 3 Airflows or 4 Airflows or 5 Airflows. You can even use this as a feature, having a separation of concerns, having a certain type of DAGs, for example, all your machine learning DAGs on Airflow 1, all your ETL pipelines on Airflow 2, etc. And this actually also gives you better access control. You can separate which teams have access to which Airflow. And although you can do this in Airflow with the direct access control and have different levels, here you can do so on a DAG level in a much easier way. But is it really that easy? You have to do even more work to set up more Airflow instances. You require even more resources because every single time you pop up a new instance, you need more cloud resources. You need another scheduler, you need another database. And all of that stuff needs maintenance. All of that stuff needs regular operations. And if, God forbid, you have to upgrade to Airflow 3, then you have to upgrade all of your instances to Airflow 3. So now that you have an idea of the hell that I live in, what happens if you have data-aware scheduling and you have separate Airflow instances? Well, you start to wonder how to synchronize Airflow datasets. So at work, this is what I work on. I had an older instance of Apache Airflow 2.4 with about a little bit over 1,000 DAGs with development frozen on it, Python 3.8, and we were migrating the DAGs from this instance to a younger instance in Apache Airflow 2.9 with about 600 DAGs on it in active development and Python 3.10. This was before Airflow 3 came out, so now we have another migration to do. So how do we synchronize the Airflow datasets from the older instance and the younger instance? Because if we don't synchronize them, then once I start moving DAGs from the old instance to the young instance that depend on datasets that are hosted on the older instance, they're just going to stop executing. Well, the first crazy idea I had was using custom high-frequency DAGs. The idea is, on every single instance, I'll create a DAG that will continuously run, and every single time that Airflow instance creates a new dataset event, is just going to take it and push it to all the other Airflows via the API. This is fairly easy to do, and if you had decent knowledge about Airflow, you can do it. The two issues that I had with this solution was, well, first of all, if I can push to all the Airflows except a single instance, I have to deal with handling the errors for that instance, so my DAG cannot stop running until it has successfully pushed, or I have to do some error handling, like store the data for a later date. So that's a little bit annoying. And the other problem I have is every single Airflow DAG has to push to every single other Airflow instance. So if I have n Airflow instances, I'm going to be producing n times n minus 1 messages. So that's O of n squared messages. That's not great. My second implementation candidate was there was a new feature that came out at the time called Airflow listeners. And the thing about experimental features is that they're new and they're exciting and you really want to use them. But I never really got it to work. Yeah, this was around I was using version 2.9, version 2.10 had just come out, and I just never managed to make Airflow listeners work on 2.9. So I don't know, maybe you can explain it to me. But yeah, and after a while, I stopped trying really hard because I found that listeners are an advanced feature of Airflow, and since they're not isolated, this big red message on the Airflow documentation kind of scared me. So I decided to try to do things a different way. And so we finally reached the last solution, the one I didn't really want to do because it meant a lot of more work for me, using an external service via the Airflow API. So the good things about an external service is that since things run elsewhere, they're not running on Airflow, so you're impacting the Airflow resources a lot less. Also, I only have to do 2 times n messages if I have n Airflow instances. This scales pretty well because I do one message to get all the Airflow datasets from all the instances. And then in the worst case scenario, I do another n messages to give every single instance the Airflow datasets that it's missing. And because I'm using custom code and I'm hosting it however I want, outside of the constraints of Airflow, the error handling is a bit easier. So this is the solution I chose, and this is the solution that I'm going to be describing to you today. So the way it works is I have a service hosted in Kubernetes that has a group of producers and a group of consumers, and it queries all the Airflows to get all the data sets, pushes them to a single Kafka topic, and then the group of consumers queries that topic and then pushes the Airflow data sets where they need to go. I've used this setup for 2 instances, but I've made it so that it can scale to as many instances as I need. So the first thing we need to do for that is we need to pull the Airflow datasets via the API. This is fairly easy and direct. You have a dataset events endpoint that gives you new events every single time that an event is created. So a dataset is the unique string that we mentioned earlier. A dataset event is every time the underlying dataset changes, we create an event. And so by pulling these and basically making sure that I always pull them at the correct offset, I make sure that I'm not missing any events. Then another one of the advantages of this method is that I have now a single source of truth for all of the dataset events across all of my instances. I can go directly into my Kafka topic and look at my dataset events, and I'll be able to know what events were produced when, on what instance, and when they got into the Kafka topic. Another one of the benefits of the solution is that it separates the concerns for every single, in my group of producers and in my group of consumers, for every single Airflow instance, I've made a different pod that does the job of only dealing with that instance. That way, if one of my instances dies or if one of my pods dies, I will only be stopping part of my processing and the rest of my processing can keep going on in the worst case scenario. And I've saved the offsets of both the producers and the consumers in the Airflow variables for the one and directly using the Kafka offset for the other. So this all sounds very nice and good, but we all know reality isn't like that. So let's talk about what went wrong. Well, first of all, I'm using Airflow 2.4, and from the Airflow development point of view, that is dinosaur stuff. So Airflow 2.4 API does not have a post endpoint for dataset events, and the Airflow 2.9 API does have a dataset events post endpoint, so I can create new dataset events directly via the API, but I cannot create dataset events for new datasets. dataset events, datasets. Sorry, and the question here is, how do we propagate dataset events if we're not allowed to create new datasets? To answer that question, we have to go a little bit deep into the internals of Airflow and compare things that are called parsed objects versus created objects. So parsed objects only exist in the database as basically references to the underlying files that are currently being parsed. For example, DAGs, tasks, and datasets. It's all written in your code, and when Airflow reads it, it puts a reference in the database, but essentially your code is the one who's telling Airflow where that stuff is. This is as opposed to created objects, which are DAG runs, dataset events, and XCOM, which can be created at any time and basically only exist in the database. So the problem is, what happens when your files and your database don't agree? Well, because the Airflow devs don't want to deal with this question, I can't create new datasets through the API. So one of the solutions I found to this problem is dataset alias, which is an Airflow feature in 2.10. The dataset alias allows you to call on a DAG without knowing what datasets it's going to impact at design time. So when you write your code, you don't write what datasets are in it, but you will write code that will allow you at runtime to know what datasets are in it. That means that when you write your DAG file, the dataset name isn't in there, but when it runs, the code will receive the dataset event. And another one of the advantages of the dataset alias is that it also doesn't need to know how many datasets it's going to be impacting. So by using this, when my consumer runs, if I find a new dataset, then I can create it via the dataset alias. If I find a dataset event, but that has an existing dataset, I can push it through the Airflow API. And if I find only dataset events that are not new, then I don't have to push anything and I just update the offsets. What's important to note is that if an instance sends its data late because it was down and it's coming back up, I will also do a check on the local instance before pushing it to make sure that the data I'm pushing is more recent. Because like we said before, I want to know when my data source changes. So I need to make sure that there has been a change and that change is more recent than the last time I updated my workflow. So the consumer pushes to Airflow 2.9. Wait, no, dataset alias is a 2.10 feature. All right, we upgrade. Pushes to 2.10 via the dataset alias DAG. If the dataset event has a dataset that already exists, then it pushes through the Airflow API. And when we're trying to push to 2.4, well, I don't have any solutions there, so I had to do the dirty SQL queries that Wei Li said we're not allowed to do anymore to make it work. Of course, the Airflow devs know all this. That's why they gave us some nice stuff in Airflow 3.0. So not only can you use the dataset, the dataset aliases, but you can also use a new API endpoint called materialize asset, which creates new datasets directly from an API call. And that was my solution. So now that we've talked about this, I'm going to give you some information about how we use Airflow at my job, and then we'll have time for questions. So at Numberly, we use 5 different Airflow instances, one for testing. Basically, before every single Airflow upgrade, infrastructure upgrades this instance and makes sure that everything will work. Then we have 2 for development and 2 for production. Both our schedule and our workers all work on Kubernetes. We host our own Kubernetes cluster on bare metal servers, and we use the Kubernetes executor to run it all. The Airflow setup is done via Airflow on the Helm charts, and our DAG deployment is done via a networking file system, because before that we used to use Git sync directly on the instance, but we DDoS'd our own GitLab instance, so we had to find a more efficient way to do it. So now we have a custom Git push services that pushes to the network file system, and then the network file system that is directly used by the Kubernetes pods that need access to the DAG files. Finally, the last point, which I think is interesting for people who run Airflow in production, is I've heard that a lot of people use Airflow and produce a Docker image for every single DAG. in my company, we found that wasted a lot of time, and data engineers' specialty was not creating Docker images. So we basically use one big Docker image for 90% of the DAGs that has a group of agreed upon dependencies that everyone can use. That way we streamline the development process. But what that means is that if you don't fall inside the bucket of the agreed upon dependencies, you have to solve it on your own using either the Python virtual environment operator, or you have to use your own image, push it, and then use the Kubernetes spot operator. If you want to know more about Numberly setup, you can see my podcast appearance on the Astronomer Data Flowcast. This is the link to the podcast on YouTube. I'll give a minute to everyone who wants to take a picture, and then we'll move to question time. All right, that's it for me. Thank you very much for your time. And if you have any questions, I will answer them now. All right, I'm going to answer the questions from here because it's not on my screen. So the first question is, how about the latency of the external service for sync the diff instance? Can you share the resource usage of Kafka service when the task is running? Oh, yeah, actually I wanted to touch on that. I need to get my slides back. Up. Yeah, so here, if you look, so this is blurred because obviously it's company data and it's private, but here you have the date and timestamp of all the Kafka data. And if you look at it, you'll find that because the events we're tracking are changes in data, they don't happen so often. Like it's not multiple tens or hundreds of events per second. We're more at like maybe 10 events per minute, something like that. So the latency here isn't this much of a problem. And we are a data marketing company, so our Kafka topics are used for much heavier, beefier workloads like tracking real-time bidding and people's clicks on websites. So because we're orders of magnitude under that in terms of like data frequency, data velocity, this is actually not a problem. It's not something we consider when building this solution. And the other question was, can you share the resource usage of the Kafka service when the task is running? I mean, I guess I sort of answered that, but I can get some stats on the resource usage of my whole solution and share them later. Yeah, no problem. I just have to double check with my company. All right, can you clear this? Yeah, I'll go to the next one. If you can wish for one dataset, asset, feature, anything, what would you want it to support? Well, while I was doing this, I kind of wanted something like the current Asset Watcher feature. So I kind of feel like my prayers have already been answered. It's just, I've already developed a whole solution, so now I have to I have to go back to my company and say, hey, Airflow already implements this. Can we get rid of it? I don't know. I'll have to compare I'll have to compare the performances of both, but I have a talk at the Airflow Summit about comparing the performances between the Airflow solution and my solution. So once I do that, I'll be able to know whether or not my gifts has been given, my wishes have been answered. Do you think Asset Watcher in Airflow 3 can reflect again on that? Well, yeah, maybe. It, like I said, there's a difference between events and dataset events. But if I can implement my own trigger to do things the way I want, probably. The only difference is I have to watch how much Airflow resources are being consumed by the Asset Watcher and the whole Airflow triggers thing, because we don't usually use those in production because we have so many DAGs, but maybe. Please tell more detail about why 90% usage of big container image. So for this thing, when you develop on Apache Airflow, you're running Python code. Your Python code needs to run somewhere. And we're developing on Kubernetes. So every single task runs inside its own Kubernetes pod. And that pod needs to, have some underlying kind of VM thing to be able to function. So it needs basically a Docker image. And data engineers, they're very good at ETL, they're very good at Python, at least in our company, but they're not as proficient as maybe software developers or infrastructure guys at dealing with Docker and Kubernetes stuff. So if you can take that completely out of the pipeline, you gain a lot of time because people work better at things they're good at and work faster, even though they want to gain some experience. So what we want to do here is we want most of our jobs, most of our ETL pipelines to not need any Docker or any infrastructure work. You just push your Airflow DAG to the mono repo where there's all of the Airflow DAGs, and boom, it's directly in production after you've been reviewed and all that. Of course, we're not barbarians, but and so that's what we're trying to do with this. We have all the basic data science, data engineer, Python libraries installed. We have the underlying C binaries that you need. It's a pretty big image. If I'm not wrong, it's like 6 or 7 gigabytes. And it also has all of the Spark and Hadoop binaries because we use Apache Spark. But that means that once we've built that image, and we need to rebuild it every time there's a migration or every time there's a change, but the infrastructure takes care of that. Once we've built that image, the data engineer can do their job without having to deal with that. And that allows us to also hire more data engineers and more junior data engineers because they don't need to know all of our stack to be able to work with it. And once they're working in your company, they can slowly gain those skills. We've already answered this one. Yes, this is interesting. Serverless. So my company tries to work as much as it can with its own resources. That's why we have our own Kubernetes cluster on bare metal servers. But in 2025, you have to work with clients, and your clients all work in the cloud. So we do work a little bit on GCP, AWS, and a little bit less on Azure. But we try not to host there because the costs for a tech company are so prohibitively high when you start to scale. And because our tech expertise is of value to us, we prefer to build things ourselves and host things ourselves. So I don't have a lot of knowledge on the Google Cloud or the AWS managed Airflows. I wouldn't be able to tell you if it makes sense from a business perspective. But I think it really depends on your organization. If you're a startup or if you don't care about fostering tech knowledge and about people, becoming, I guess, very technically able in your company, and you don't want to create an educational path to being an experienced developer. If you just if you're a bank or a financial institution and you just want things to get done, then I'd say, have as little tech as you can and just pay the bills. And if the costs go up, that's the risk you're taking. How to monitor if an event trigger does not trigger within the expected time. This is more a question for you, no? Do you want to answer it? Because this is Airflow triggers.
I hope you can check the log somewhere. Technically you can log something in the trigger. But you need to monitor the log. So there's another thing you need to monitor the monitor. So there's a way, but it's I don't know. But
his answer is check the logs.
Yeah, check the logs. Remember to add the logs and check it. Yeah.
Next one is, do you use any other tools to monitor your entire pipeline, like Data Hub or Open Metadata? Actually, this is a good one. We haven't talked about this, but Airflow supports stats and Open Metadata out of the box. And we've plugged it into our solution, which is Sentry. So yeah, we do use Open Metadata, and we push our Airflow stats to Prometheus, and then use that to have Grafana for monitoring. and it sends alerts and all that kind of stuff. Aren't inlets just datasets?
Not. It's kind of it's a way you can access dataset events, but I always feel this feature a bit interesting, so that's why I'm asking.
I wrote that. Quick answer, no.
Okay. What are inlets and how do you use them?
Quick answer, you don't. Long answer is we are building that.
Okay.
Yeah. Eventually, you should be able to read data from an inlet. So you can send data when you send an asset event from an outlet, and you can read it in an inlet. That's how it's supposed to do. But the data sending part has not been built. So currently, yeah, inlets aren't that useful.
What is the difference between an inlet and a trigger?
No, you can send actual data through the wire, so to speak.
So you could send the delta in your data source and
whatever you want. Yeah.
Oh well, we don't use inlets yet. Maybe. So right now we have our Kafka topic only has a single partition because that way we don't have to deal with multiple partitions in terms of querying. Is your partition number of your task 1-to-1 with Airflow DAGs? 1-to-1? No, we have a single partition. All the data sets from all the DAGs go in there. There's no reason to partition up unless you have a problem of volume. And like I said here, the data is not that fast, not that volume. So we're able to deal with it with one partition, and that makes everything much simpler. How do you maintain your topic when the DAG number is changed? Well, so far the DAG number has not scaled to a number that's high enough that we need to increase the partition level. So I haven't really had to deal with this problem. But like I said, we have this kind of problem a little bit more when we do the ingestion of real-time customer data. For example, my company has about 100 clients. A lot of those clients have websites. Every single visitor from every single website creates a bunch of events, and we ingest all of those events through Kafka. So in those kind of scenarios, we do have a very highly partitioned Kafka topics, and that's when we need to deal with that kind of problem. In multiple... Is that me? In multiple instances, will the rerun difficulty increase when DAGs failed? DAG instance A, DAG instance B, DAG instance C. So I'm not sure what this question is talking about, but it's great because it lets me talk about something else that we did that I haven't talked about in my talk. One of the nice things about Airflow is you can create your own operators. And one of the typical operators that people use is the Airflow DAG trigger operator, something like that. It just allows you to trigger a DAG from another DAG. But when you have multiple instances and the DAG you want to trigger is on another instance, you can't really do that. So we've built our own external instance DAG trigger operator, which inherits from the classic trigger operator. And that was a very interesting thing to do because that operator has a little button on the Airflow interface. And whenever you want to change anything on the UI, because the UI is not loaded when your DAG is loaded, you have to do it through a plugin. So if you're a developer and you use Apache Airflow, I highly recommend that you try to get some experience with plugins because it looks very hard and it's very powerful, but it's actually not that hard. All you need to do is create a package. And in the pyproject.tomo, you basically reference Airflow so that it takes it in as a plugin, and it makes it very easy to customize your Airflow setup, specifically the UI. So now on our instance, you have a little button where if you click, it'll take you to whatever instance the DAG is on where it should be running. It's just Ubuntu, but the window manager is i3. And I think that's what you're referencing when you're asking what's the cool OS. How large is your data team? Could you share the daily work structure? Sure. So our data team, we have separated teams for data science, data analytics, and data engineering. Our data engineering team is about 20 people. We have maybe 5-6 data scientists, and we have maybe 8 data analysts. But the data analysts are not like the other teams. The other teams work together. The data analyst teams are spread out among the business teams. So they only group together to talk about tech, but they work amongst the business teams. The data science and data engineering teams are grouped together. And the daily work, well, yeah, generally we, how do I say this? We have 2 different types of work, I guess, like most companies. You have your ongoing big internal projects that you work on whenever you have time. And then you have more short-ranged client requests when a client wants an ETL pipeline, or there's a GDPR request because my company is French, so we have to deal with GDPR. So basically, we have a weekly meeting on Mondays where we define who is doing what. There's a team of 2 project managers who share that responsibility. The rest of the project managers interact with the clients, structure the demands, and then come see us telling us what needs to be done and when it needs to be done. And then those 2 PMs who have to deal with the daily work kind of interact with the senior devs to try to make sure that everything that is planned on everyone's plate makes sense. And then your work is basically spread out in the week. Between the shorter, easier ETL workload and the bigger, longer term projects like this one. Could you please share the motivation to run Airflow on KVS instead of using Argo? Well, I've never used Argo workflow, so I wouldn't know. If you've used Argo workflow, please come convince me. If it's better, I'll use it. I don't mind. I don't care. Have you tried Airflow 3? What do you think about it? So I've only tried it on my machine. I like the UI. And I think there's a lot of new features I want to try, but before I try anything else, I really want to try listeners again because I'm a little bit frustrated that I couldn't get that to work. Yeah. Would you need an Oh, that's a good question, actually. Why would you need an asset event on an instance if that instance does not have the asset? You don't. You don't, but by the time you realize that you need it, what are you going to do before you migrate the job? Because we have a bunch of assets, and a lot of our processes are standardized, meaning that for every single client, as long as I set up the default ETL pipeline, I produce maybe like tens or 50, dozens of events for that client. So if I have to set that up last minute before I have to set up a new job, it's going to be problematic. There's not that many dataset events. I might as well produce all of them on all of my instances. And if it becomes a problem, then I'll implement the code to selectively push them. But until then, it's easier for me to do this, and it allows me to test the process. So I just went ahead and did it.
Wait. Okay. Thanks, Seb, for his wonderful sharing. And let's give him a big applause.
Thank you.
Thank you. So again, if you have broader topics or ideas you'd like to discuss, please try to do after a session. Thank you very much.